Hello, everyone. Thank you so much for being here with us today. Let me set the stage a bit. Imagine having an opportunity to build an AI companion at Microsoft entirely from scratch. And that's exactly what the journey we embarked on. And I'm really excited to share with you today. My name is Vish, and I'm joined by my friend and colleague Amos. We were among the first ones to kick off this project, and it's been an incredible journey architecting the app from the ground up. Before we dive into the details, let me give you a quick overview of what we'll be covering today. I'll start by sharing a bit about what Copilot is. I know there are a lot of variants of Copilot at this point. Then we'll talk about the challenges and pain points we strategize for, and do a technical deep dive into our solution, walk through code, and then we'll open it up for some Q&A towards the end. So chat is a big part of most AI companions we use our day to day. But before we get into that, let's take a look at what else does Copilot bring to the table. So on the first card you see is what we call the Discover card. It's where it shifts conversation to more contextual, surfacing personalized weather, news briefings, and even on-demand podcast playlists, just tailored based on your context. Next is we've also added voice and vision to allow you to speak naturally with Copilot if you prefer instead of typing, or if you prefer doing multitasking. And towards the end, the last picture is of a digital assistant. You can ask Copilot questions quickly, set reminders, control your devices, just like you would with any other digital smart assistant. Now that you have a glimpse of what Copilot offers, let's take a step back and look how we got here. Our short journey started from April in early 2024. That's when our first PR got in. And in a few short months, in August, we had an internal launch. By October, we went public. And by December, we were at 4.8 App Store rating and at 12 million active devices. Now, getting there came with its fair share of challenges. Our goal was to replace a 10 million downloaded app in just 6 months, while scaling the code base to support multiple teams contributing to the same code base, over 20 teams, in parallel. All of this with lean squads working in fast-paced 6 to 7 week cycles. Now, what do we strategize for? How do we prepare for this? So one of the things is, let's start narrowing it down a bit. So let's take chat, for example. Now, a lot of the conversations with AI is happening in chat. Now, everyone starts contributing in chat. It's going to happen that you're going to run into a lot of merge conflicts. And then feature logic leaking across modules. And then how do you define ownership? There are so many teams working on it. What happens when something fails? Who's taking ownership of it? Who's taking accountability of it? So all of these factors which can make contribution messy and slow. So how did we improve on it? So this is one example. So we started with simple text-based chat, and then we layered in Markdown to support richer formatting. So now that'll allow links, tables, some styled content. Now, to go beyond that, we needed interactivity. So we wanted Copilot to have rich contextual responses like recipe cards, or quizzes, or maps, or shopping results, and more. Let me show you a brief of what each feature does. And so you get the gist of what it looks like, and you can briefly think about what it would look like to implement this feature. So looking at the recipe card, I'm going to ask for a recipe, and it's going to give me a result of a bunch of recipes that it finds. We've also partnered with different, like here it shows Instacart. We've also integrated with different companies to allow for that cohesive experience. So here I'm able to integrate with Instacart, order my ingredients, sign up based on my account, and move on from there. Next, let's look at quiz cards. This is popular among students in schools and colleges to have you some questions, and it'll prepare your questions based on what you're asking, what it knows about you, and build a personalized quiz for you. Again, like think about how it is interacting in chat, how it is interacting with the bottom sheet, how it is updating sheets, how it's updating states both in the background for the card and also in the bottom sheet. While we are going through the answers or the question and answers through it. Now, as I finish the quiz, not bad, 3 out of 2. I can see the summary and results, what's wrong, what's right, explanations. We also have math-based quizzes as well that allows you to do like LaTeX rendering and all of that as well. Let's take a look at one more example for maps. So we integrated Bing Maps here. Microsoft has a lot of built-in ecosystem, so we had Bing Maps come for free for us. All of this is Compose first, but there are some aspects which is not Compose friendly, but we were able to integrate it in this. So that's also a key thing to look out for. So these interactions of like moving with 2 fingers, making sure it deep links into the right maps that your device has, what does that look like? So now that we know what we wanted to build this rich answer cards, or what we call answer card, but rich contents. We had to make it easy to build. One of the most effective early wins was adopting convention plugins to simplify and standardize our Gradle setup across modules. So what does that look like? So instead of duplicating build logic across modules, we encapsulated all of our shared defaults in one place. So here we look at Android feature convention plugin. So what we need is like compile SDK version, compose, dependency frameworks, so anything else that we have shared UI frameworks that we want to share across modules. So what does that look like when we build a module? So now adding a new module becomes incredibly simple. Just apply the right plugin and you'll automatically inherit all the defaults and guardrails. So on the left is our traditional Gradle file that will look like it. And on the right was just importing the right convention plugin, and you have everything else for free. This kept our Gradle files clean, reduced the config drift, and saved us from the subtle inconsistency that grows as new people add new modules across codebase. We also took a step further and made an Android plugin so that a click of a button, it'll generate a module for you and get you across the line. So now it's easy to spin up new modules. Let's talk about our next part. How do you make those answer cards and what kind of framework we would use for that? To walk you through it and show them in action, I'll hand it off to Amos.
Thank you, Vish. We developed a modular framework called Answer Card. So what's Answer Cards? Well, we have already demoed a few of them. They're the rich contents that we show you to the user. And today I'll be showing you a subset of the framework and how we implemented this framework. So this allows the engineers to contribute to the code in parallel without running into each other. Okay, so before we dive deeper into the implementation, let's begin by taking a look at this simple module dependency in the chat screen. Here we have, the user sent a message, and then the model responds a text message. Very simple. So we have 2 modules, app and chat. And chat has this package text. So, but, just showing text is kind of boring. Reading through a wall of text to get information is just not the way to deliver information. So we need to have like a little bit more of our interaction, engaging, and dynamic features. So let's try to add a finance card. Like I want to look up, information about the stocks or the financial statements of a given company. So we could add it as another package under chat module, but this can become a problem quickly as we have more features coming in, like weather, images, videos, sports card. We only show a subset of there, like close to 20 features right now, and some of them are in flight. So they're all happening simultaneously. So we can run into issues that we mentioned earlier, like merge conflicts, code smell, negative velocity impact, and ownership issues. So the way we tackle this is by first creating a new module called answer, and it will abstract the provision of these answer cards. Of course, this is just a simplification of the answer module. We could further extract it into UI, impl, and API modules as needed. For now, we would just keep this as just one module. And so further, the answer card module depends on answer text and then answer finance. So by doing this, we're abstracting the implementation detail of these features from the chat. Okay, now let's put all this back together, and this is the dependency graph that we have for the modules. Here, app depends on chat depends on the answer, answer depends on this individual features, and chat isn't aware of the UI or business logics for these individual features. This looks pretty straightforward. Now let's look at some of the code snippets to get more details. Okay, so we are going to be implement this view. Is stock chart where you can swipe through the graph, and it will show you the price actions, and it will show you the timeline, and you can swap through. So it's just like a quick overview of the stock. So how do we start? First, we create a new module. So on the left side, we're showing you the list of modules just to give you like a indication of where we are right now. And then on the right side, we'll have a snippet of the code. So in this Gradle file, you'll notice that we're applying a plugin from the version catalog. Let me do the tiny thing. Where is it? Where? This one? Yeah. Okay. Oh, there you go. So this Gradle file, you will notice that we're applying a plugin from version catalog. This is a plugins Copilot native Android features. So it is the convention plugin that we created and registered that Vish has shown earlier. The plugin will bring in the necessary configuration, so we don't have to redo all of those things. So it's a pretty slim Gradle setup. Next, we will write the UI of the finance card. So here in this composable, you will notice that we're creating a view model with the assisted injections. The idea is that we want to isolate the business logic to their own view, and unless states are needed outside of the composables, we are using Hill view model for this to achieve that. So you will also notice that we're passing a unique key to create this view model. This is to create an individual instance for each finance cards. One thing to be mindful is that when we're passing the key, it must be unique across all view models, regardless of the type of the view model. So this is one of the issues that we run into. Because we had the wrong assumption. So let's say that we're passing a key, let's say ID of 1, and then it is for finance card. And let's say there's another card, let's say, recipe card, and it also has ID of 1. Then whoever is created last will replace the view model of the prior in the view model store. So the next time when you have a recomposition, you will be creating a new view model. That's just like one gotcha to be mindful about. So now we have the UI. Let's look at the UI model and what we are passing into the UI model. So we are passing like a type of finance card, and it extends to an interface called answer card. So the interface is base interface for all the answer cards UIs, and its purpose is again to abstract the host from being aware of what type of answer card is being passed. Um, and then we will further explain it later on when we are converting the AI responses to the UI model. Of course, we would like this interface to be a CO interface, but it is not feasible since all the modules that are extending to it are outside of it. Okay, so let's go to next. Okay, so now you have the UI. Now we want to register the UI in the like a UI factory. Um, so so on the left side, you will notice that like this file is living in the answer, and this is gonna be called by the chat, and it is it has dependency on all of these individual answer cards. So then we can iterate through the type of the answer card, and then properly produce the composable. Now we're done with the UI layer. Let's get into the data layer next. Okay, so here we have a sample of JSON blob of the AI response on the left side, and then deserialized class of it on the right side. On the right side, we have two classes. One is answer card data, and then another one is finance card data. Finance card data extends to the answer card data. Again, the idea is still the same, which is that we're creating a base class in the answer API, which is agnostic of the feature, and then we have individual features that are extending to that class. Here, we are using Kotlin serialization library, and we're leveraging this feature called polymorphism from the library. This feature includes the type metadata type, which is like right here, into the serialized data. And during deserialization, it is used to look up the correct subclass and recreate it. So the type is the default name that they use, so you don't really need to pass it here. If you're using serialization, it will just do it. But let's say if your data the meta hint is different, like let's just say class, then you will need to provide a annotation with the matching hint here. So it will be JSON class discriminator class. So so let's talk about why we are using this. Well, it gives us two things for our needs. The first one is the concrete class that we want. For example, the finance card data from the JSON blob. The second thing is that it provides the ability to register concrete classes across modules. Okay, we define the base class in the answer module and register the subclasses such as finance card in the answer finance module. These two things allow us to isolate the finance card. And then at the bottom, you see that the first step is that we call this polymorphic function, and then pass in this base type, and then we edit the subclasses. So we have this mapping of class hierarchy, and then we register it as a serializers module. And then we're actually providing this whole serializer module back up to the implementation. So and then we're using into set to provide that. So let's see where we are injecting these. Okay, so one of the areas we inject the serializers module is inside of the network module. Here we're using retrofit. The network module is agnostic of the features again, and the map of the serializers are added to the JSON config, allowing us to deserialize in a plug and play style. So here we are injecting the serialized modules, and we loop through each one, and then we combine all these modules into a one, and then we assign it back to the JSON config, and then we create the retrofit. Okay, so now we have set up our data layer. Let's see how we wire the network data to the UI model. Okay, we have a class called answer card UI model converter, which takes the generic type of answer card data with a function called convert, and then it returns the interface answer card. So these are all public APIs, and they live in the answer API module. The purpose of this interface is to convert the AI responses into the UI model. Next, in the finance module, we created the actual implementation of this converter that accepts the finance card data and then return the UI model. So how are we providing this? In the module configuration file, we're using the multi-binding again here. We're using into map, and the key being the data type of the finance card, and then the value being the converter. Okay. So we are providing one type of the finance of the UI model converter, but there are tons of features, right? So we need to have we need to inject all of these converters, and then properly select the correct converter in order to convert to the UI model. So we added another layer. So then that consolidates all of these answer card UI model converters, and then we provided a public interface called convert. So what it does is that by doing this, chat doesn't need to do this. All it needs to do is inject the answer card message converter and just call convert whenever it receives an answer card data. So that's the idea of it. So now let's take a look at how we chat view model is using this interface. Okay, so there's when after the user send a message, AI responds, and then we in the view model we handle the answer card message, and then we simply just call the answer card message converter.convert. We don't need to traverse through the type, anything like that. So it's pretty simple, straightforward. And then again, chat is still unaware of what type of answer card it is. And then after converting, the UI model is added to the list of the messages in the view state for the chat screen. And now chat screen is going to recompose. Okay, so after chat screen has recomposed, it will go through each type of messages and then pass the message model into the answer card view that we created earlier. So here we went through each one, and then we passed in the model. And here the answer card comes in, and then if it's the finance card, we just show it. Let's see the demo actually. I have to disable that. Here we're asking for Microsoft stock. Okay, it's $4.90. I think it has gone out a bit this morning. Here the user is going through the timeline, and then and then they can also tap into see more to look at the financial details of the company. Right here, we're generating the summary using AI. This part is a web view, but as you can see, the design, the components, UI, they're all still cohesive. And details of it. Okay, sounds good. So, okay. There's like a click listener too. So how do we do that communication, right? When you press and hold onto the answer card, and then we want to show a dialogue. So let's talk about the communications. Um, so like in order to send back interaction information back to the parent, we created an interface called answer card interaction. This is still living in the answer API module. Um, and then the child or the individual answer card that wants to send back specific like answer card interaction events, they will implement this. For the ones that are kind of general, we just define it at the parent level, which is the like on long press card, that can be applied to any of the answer cards, right? So here we're just using a simple callback. Um, um, so this concludes the general idea of our modular framework answer card, but we still got a few more slides. Um, so this allowed us to move fast, and then like add features simultaneously. Um, but just because we can go fast doesn't mean that you know like we don't care about safety, right? We have to wear helmets and then have safety checks. So let's look at what strategies we use to have these safety checks. Safety is cool. Okay, so these are some of the safety measures that we used: client feature flags, client capabilities flag, and the default serializers. So we have two type of flags: experimentation and then kill switches. One is used for general, experimentation, feature flagging your feature when rolling out, and then the other one is used for shutting it off during an emergency. In our case, we added the finance answer card behind this feature flag. Yeah. And then the next strategy is client capabilities flag. It basically tells the backend what type of AI messages our client can support. And it also supports backward compatibility. So for example, when finance card is launched, users in the new app version will receive the finance card, while the users who haven't updated their app will receive the text response. Yeah. So and on the in the slide, we're showing the timeline of the flow when and how we send the capability flag. When the app starts, we acquire the client feature flags, and then we establish the WebSocket session. This is how we send messages. And then as soon as we have connected the WebSocket, we send a list of flags to the backend, letting them know what type of UI that the client can support. And then you send a message and they receive with the type of the card. Okay, sounds good. So the next one is default serializer. This is the last one that we use. Here we register a default serializer. If it fails to deserialize. So again, the base class being the answer card data, and then we added a new unknown card data type that extends to it, and then we passed it as a type for the default deserializer, and then we provided using into set. But what it does is that if anything fails, will always be mapped to this type, and then on the client side, you can filter and then show appropriate message, right? Instead of just like not showing anything or just crashing. Okay, sounds good. So in summary, use abstractions such as interfaces and modularizations. This allow teams to develop independently and own their own features through loose coupling. Number two, leverage multi-bindings such as into set and into map, just like in the example we show, allowing the clients to be unaware of the specific implementations and allowing these implementations to live in a separate module. Three is that be safe. Yes, we move fast, ship a lot of things, but at the end of the day, 99% of the users do not care about the implementation of the technical implementation of our app, right? It is our job to create a delightful experience for our users. So have safety checks. yeah, I'm gonna give it back to Vish to share some more results and closing remarks.
Thank you, Amos. Um, Hopefully, we were able to summarize in a bite size. So, what were the results? We delivered on time, we delivered AI at scale, and did it fast. We managed to ship Copilot with multiple features in 6 months, with over 20 teams contributing simultaneously. Maintained a 99.99 crash free rate. That's very rare to find that in Android world, but we do that. And each team has their accountability and ownership of their code paths. If there's something going wrong, like Amos mentioned, we can always turn the feature flag off. The teams that built it can have ownership and they can fix it. They have their own incident systems and take care of it. That's all for today. Thank you so much for being here. If you'd like to dive deeper into the architecture or would like to know more about what we're building at Copilot, come talk to us after the talk. We also have a booth at the end next to the lounge. And yeah, and let's open up some questions, open the floor for some questions. Not too hard of questions, please.
Hey, thanks for the talk. When you're talking about other squads owning UI that all bubble up into the same screen, how do you make sure that the UI is consistent between modules that are consumed by a different screen?
Yeah, I think that's a fair question. How do you make design systems are like consistent or standardized across different teams? Yes, that's I think partly we have gatekeeping at design level as well as code level, where not just from I'm not saying gatekeeping by PR views, but also structure of like theming and colors and sizes on like shared shapes. Most of the times, if you look at a card, the card shape is going to be similar across all cards. You need to fill in the content. Um, so one way is that, and other ways PR reviews. We are very aggressive on PR reviews. We have very high bar, and then that's on the code side. But it still needs to be managed on design system side for designers, where there are multiple designers working on different teams. They also have a council where they need to go through, or their own review process that they need to go through, so that there's a standardized approach and it feels very cohesive. But that's a fair question. It's very easy to go away of the same flow. Yeah, thank you.
So first of all, congrats to both of you. That's a really tight timeline. Can only imagine how crazy that was. So I was just thinking about how the experience is kind of tailored, and you really want to be deterministic about what type of response is going to look exactly like. You have a limited set of responses, and then you also have the tie-ins with the sponsors and all of that. So I was just wondering, in your experience working on this and from what you've seen from users so far, where's the balance between um, making more data available to the user and having like a more convenient or tailored approach for somebody using the app?
I think you were asking how do we provide like dynamic content, right? That are so not just like default. Like for example, this finance card view will be available to 100% of the same users, and then they all will be seeing the same UI. But you're asking, how do we provide a customized UI? Is that what you're asking?
I mean, yeah, essentially, like, as compared to if you just go and use, an LLM, like you're gonna get a lot more. It's open ended in terms of the response.
Yes.
So like over here, it's more controlled.
Mm.
So like, where do you find that balance so that it's still, you still have a lot of utility for the user, but it's something where it's like a little bit more of a tailored experience.
Yes. Really good question. So right now, we do data massaging at the backend layer when the model is responding, massaging the AI responses. In the future, we're going to be working on the generative UI content for the user. So these are going to be largely driven by the AI, right? So it's going to be a new framework as well. Right now, it's pretty controlled. Yeah.
Hello, thanks for the talk. I have two questions. They're related. Um, is the same kind of architecture is the same kind of architecture applied to your iOS app as well?
Same kind of.
Same type of architecture on iOS as
Yeah, yeah. We're actually following pretty similar architecture on iOS and Android. So then, like, we are always in sync. Yeah.
Did you consider using any of the cross-platform strategy to share code with iOS?
Ah, that's a really good question. It is possible with a lot of the multi-platform tools that are available nowadays, like KMP, right? Um, we haven't explored, but that is definitely an opportunity we can look into.
Okay. My next question is, you talked about how you architected the app, how you strategized your process, work with different teams to sort of share the ownership with the features. Have you ever considered rendering or having your features in some other app? For example, in Microsoft, I have Outlook app. If I want to render Copilot things in the Outlook app, how would it look like?
Do you want to answer that?
So we do partly have that. I think that's a battle right now, right? Like, does Copilot become the center where you can do everything in Copilot, from ordering food or ingredients or checking your email or going into Outlook and then checking Copilot? So there's a different mixed bag of what the usability is in that space. So I think that's more of a product decision of where they want to go. But I do think, like, for me personally, I would like to have everything in one place. Like, if I have my emails, I should be able to talk to Copilot about my email in Copilot, not having to switch apps. But I do understand the perspective where I'm just checking my emails. I don't want any other noise. So fair. And just to like add on to a bit of the cross-platform, I think there's still merit in we both iOS and Android both are natively being developed, and both are the implementation details are still up to each platform, but we've maintained the architecture, and that's allowed our team to like it suddenly increases our engineering headspace. Like, we have, let's say, Android has 5, iOS has 5. Now we have 10 engineers working on what the architecture looks like, and it's great. Like, you get so many ideas instead of one experience, and like Android having one experience, iOS having another experience, and then changing in one platform somehow takes 2 weeks and the other one takes one day. So there's that balance, but we've had a good we've struck a good balance so far. Hope that helps.
Yeah. Thank you.
I just thought of something right now. So I was wondering, like, when you have these ties with the different companies and stuff, do you see there being a point where you could offer the ability for individual companies to kind of specify their own cards, like something like custom cards, and have that be available to the users?
I think that's an interesting approach. I do like the idea, but as a dev, I feel a little cautious that how do I feel about external code, not knowing how it's coming in, not knowing how
Yeah.
it's formed. Right now, all the code that gets checked in, you get to look at, interact with, suggest migrations, all of that, right? I'm imagining externally that would slow down the velocity, but I guess the question would be, given a right framework, maybe that's possible, and maybe if they are able to make it cohesive. But I think there's also a trust factor when you come to Copilot and use the app. You feel that this is Copilot and your ecosystem. A lot of it is personalized, a lot of it is contextual for you. Um, Personally, I would feel like, how do you create a balance between external vendors coming in and showing you stuff without you asking for it, kind of thing. So there's a balance of how that would work out, I think.
Okay. And since you mentioned trust factor,
Yeah.
I was just wondering, like, and this may not apply to the Android app, but when you have responses coming back, um, you may have like a harmful link or foul language or something. Do you have to filter for that in on the Android side, or is that something that's done completely before the data gets in?
Yeah, I think that's completely done by backend. There's like being Microsoft, it's very, very secure in that manner where it needs to go through multiple hoops before it comes to the user. So if you're asking something that's malicious or harmful, or AI is responding, there are multiple guardrails before it gets to either way. So you could try it. There's a user banning feature that we implemented too, if you want to find out.
Is that a
But
challenge?
yeah, it's a challenge. Go for it.
Thank you.
I see one more from you.
So, what has been your favorite feature you built, and then what are you most excited to build in the future?
Favorite feature, I think. Gosh, there's so many at this point. I think one of the underrated features is vision. We didn't get to demo it today, but it's just basically pulling up your Copilot, showing it what you're doing, and just start asking its questions. And I think I've found using it more and more on my day to day, where I don't want to Google it, take a picture, then attach the picture and Google it. I can just pull out Copilot and show it, and I get a result instantly. Whether I'm at airport or like is my flight delayed, it's all very hands-free and quick, which is very surprising. And to be part of someone that built it, I think that's one of the features I really enjoy. Thank you.